In this part of the course, we will be looking at how drug molecules can interact with their intended biological targets. We'll be looking at some of the key interactions that drug molecules can have with their targets and how this can affect the structure and function of biomolecules, including focusing on enzymes and receptors. So during this part of the course, we will discuss how molecules can bind to their intended target. This section will cover drug-target binding interactions. We will discuss protein structure and how primary, secondary, tertiary and quaternary structure contributes to the overall structure of a protein. We'll be looking at the theory of induced fit and how this applies to molecules binding to proteins. And we'll be looking at methods of controlling enzymatic activity. Now we'll also examine the binding of drug molecules to receptors, and this includes looking at the concepts of agonists and antagonists, and we'll also be looking at how compounds can also bind to other types of protein targets. Now this course will take place over the next 2 weeks of term, so it will start now in week 9 and we will finish this off during week 11. Now after that there will be a workshop on this topic where you can have a go at trying out some of the types of questions that you could encounter in assessments and exam situations. Okay, so how does a drug bind to its target? Well, here we have a macromolecular target. So this could be anything such as a piece of DNA or RNA, or it could be a protein, including proteins such as enzymes or receptors. Now this macromolecular target will contain a binding site, which you can see here. And this binding site will be able to accommodate the binding of a drug molecule. Now when we initially introduce our drug into solution or into a patient, we have a situation where we have our macromolecular target and our drug molecule adjacent to each other. Well, when the drug molecule approaches closely, it is able to enter into the binding site. And so it binds into our target. Now this is a process called induced fit, which we'll cover later on in this part of the course. And so when the drug molecule enters into the target, into the binding site, what's going on? What is happening? Well, this is a close-up view of the drug sat in a binding site. Now the drug contains different functional groups, which you can see here in red, which are able to have the right interactions with functional groups within the binding site. Now what happens is the drug forms interactions between the groups within itself and the groups in the binding site, and it forms intermolecular bonds. So these are interactions between the drug molecule and the target, and it's these that hold the drug molecule in place and allows the drug to bind. Now this view is a schematic view. It's a very simple view of how drugs bind into their target. And so what are we really looking for? How does this look in reality? So this is what a drug binding into a receptor looks like in reality. So here in blue we have salbutamol that is bound into the B1 receptor. Now the receptor is shown in grey, and with the important functional groups that facilitate binding shown in green here. Now this is actually taken from a part 2 lecture. Now by the end of this course, this structure and function course, you'll be able to understand what diagrams or animations such as this show and what is actually going on within this binding site. So for example, you can see here these yellow dashed lines. These indicate interactions between functional groups on the salbutamol molecule and the receptor. So for example, here we have a hydrogen bond. Now we're going to have a look at several different types of interaction and what each of these do and why each of these are important. And we'll be doing that in this course so that you can then understand images like this once you reach part 2. So what types of bonding can we have? Well, there are 2 main types of bonding. The first is intramolecular bonding. Now this is bonding within the same molecule. So this is any binding mode that can happen between functional groups in the same molecule. And we'll look at some examples of these later on. Now the other form of bonding is intermolecular bonding. Now intermolecular bonding interactions occur between two neighbouring molecules. By definition, they are non-covalent. As I've already said, if you have a covalent bond, you are taking two molecules and joining them together to become one. So intermolecular bonding excludes covalent bonds, but we can have almost any other type of binding interaction. Now, both of these types of interaction, intramolecular and intermolecular, can determine the three-dimensional structure of biomolecules. But intermolecular bonding is the type that is most important when we're looking at how drugs interact with their targets. So we're most interested in how we can exploit functional groups within our target and put complementary functional groups in our drug molecule so that we can get these groups form intermolecular bonding interactions together to hold our drugs in place and allow them to perform their function. Now there are several key types of bonding interactions. These include electrostatic interactions, which are interactions between groups that have opposite charges. So one group has a positive charge and the other has a negative. We have hydrogen bonding, which is present when we have both a hydrogen bond donor and acceptor group. We have van der Waals interactions, dipole-dipole and ion-dipole interactions. We also have hydrophobic interactions, or interactions that are facilitated by water molecules, and we also have repulsive forces as well. And we're going to be looking at all of these in this section of the course. So in the next section, we will begin reviewing the main types of intermolecular binding interactions that you could have, and we'll look at these, see what types of functional groups can support them and what types of interactions can be formed.